Hello everyone and welcome to our video devoted to test automation for Cuba applications. My name is Gleb Gorelov and I represent the development team of Cuba platform. In this video you will learn the ways of testing Cuba applications on different layers. We will create simple unit test, integration test on middle tier. Also we will create tests for REST API and even UI tests to see if our application works as expected. After that we will overview how to configure a Cuba application to run on CI service. Unit tests can be created and run both at the middleware and the client tiers. The platform test modules bring the dependencies on JUnit and JMockit libraries out of the box, but you can use any third-party Java libraries for test automation. Let's see how this works. I'm going to use a simple sales application to show the ways of testing Cuba applications. So let's create a new order. Set date, create a new order line with product, pen, quantity 2. Create a new one order line with product apple, quantity 1. Pay attention to the amount attribute which is calculated automatically. So let me show the code responsible for this. Click OK to save the entity. Go to the studio, open generic UI section, select order edit XML and click IDE. Switch to the order edit Java. Here you can see that the order helper bin is used to calculate the order amount. Let's overview the code. So it's pretty simple method which iterates through the all orders lines and summarizes the multiplication of the product price by its quantity. Let's create an unit test for this bin. Expand the web module. Create a new directory with name test. Click OK. Now we need to execute the IDEA Gradle task. Now we see that this directory is defined as a test root. Create a new package. Set name company sales web utils and create a new Java class. Set name order helper test. And let's add the following. So it is pretty simple test class in which we set up test data and check if our calculate amount method works correctly. Let's run our test. Our test is passed. In the middle tier you can create integration tests which run in a fully functional Spring container connected to the database. In such tests you can run code from any layer of the middleware, from services to ORM. By default, when you create a project you already have a simple integration test. Let's overview it. Expand the core module and open sales test container. The platform contains the test container class which can be used as a base class for the test container in the application project. Just create a subclass in the test directory of your core module and in its constructor redefine parameters for loading components, application properties and test database connection parameters. For instance, here you can see that we will use Cuba app component. We will use properties from company sales app properties and test app properties files. And we parse the context XML file to obtain database connection parameters. We recommend using a separate test database. So let's create Gradle task to start and create a test database. Open build Gradle. Within configuration of core module, add the following. Start test DB task will start a new instance of HSQL database. Pay attention that DB port should be different from the default port used by Studio HSQL DB server. Create test DB task will execute all SQL scripts needed to create a new database. Open the sales test container Java and replace the initDBProperties method with the following. So, we will use a special test database for our tests. Also, during project creation, a simple test is added. Open sample integration test. It has a single test method which checks if the user admin exists. Pay attention that the test container should be used in test classes as a JUnit rule specified by class rule annotation. The test container starts print context automatically and setups all Cuba infrastructure bins including database connection. The test container class contains the following methods that can be used in the test code. Persistence returns the reference to the persistence interface. Metadata returns the reference to the metadata interface. Delete record. This set of overload methods is aimed to be used in after methods to clean up the database after tests. In the sample integration test, you can see that we obtain metadata and persistence object from the test container. In addition to this existing test method, we will add a new one. In this method, we will create a new customer, save it in the database, and then delete. So, first of all, we need to create a new customer. Then, save it to the database. After that, we need to check if the customer in the database. And remove the customer. Now we need to start and create our test database. Now we are able to start our tests. All tests are passed. The Universal REST API provides the following functionality: CRUD operations on entities, execution of predefined GPQA queries, execution of service methods, getting metadata, getting current user permissions, getting current user information, and uploading and downloading files. REST API uses the WAF2 protocol for authentication and supports anonymous access. The detailed documentation for the API is written according to Swagger specification and is available at filescubeplatform.com/swagger. For REST API testing, you can either use some specialized tools for manual testing or write code that will send requests and parse responses. And now I'm going to write code that will create and delete a customer using REST API. But before we proceed with REST API tests, I need to add a new dependency to simplify response parsing. So, open build Gradle. Within dependencies of web module, let's add the following. Execute the IDEA Gradle task. Within the company sales web package, let's create a new class. Set name REST API test and add the following. As the documentation says, the REST API is available at the URL /rest/v2. Before accessing a protected resource, a user must get an authentication token. The token can be obtained at the /oauth/token URL. The /oauth/token endpoint is protected with the basic authentication. The request must contain an authorization header for the basic authentication with REST API client credentials. User credentials must be pasted in the request body. Any entity can be created with the post request on the address equal to base URL plus entities plus entity name. In our case, it is entities sales customer. The request body must contain a JSON object that describes a new entity instance. An OAuth token must be placed in the authorization header with the bearer type. In case of successful method execution, a full object graph of the created entity is returned and we can examine it and check if all the fields have a correct value. In case of deletion, we need to send a delete request on the address equal to base URL plus entities plus entity name plus entity ID. So let's run our test. Our test is passed. The last testing approach that we'll discuss is UI testing. For that purpose, you can use Selenium. In fact, Selenium WebDriver. Selenium WebDriver is a tool for automating web application testing, and in particular to verify that they work as expected. Selenium WebDriver accepts commands and sends them to a browser. This is implemented through a browser-specific driver, which sends commands to a browser and retrieves results. Most browser drivers actually launch and access a browser application. To simplify code writing, we will use Selenite. Selenite is a framework for test automation powered by Selenium WebDriver that brings the following advantages: consist fluent API for tests, Ajax support for stable tests, powerful selectors, simple configuration. In other words, you can focus on logic of your UI tests. Before we can use Selenium and Selenite, we need to add dependencies on these libraries in the web module. So open build Gradle. Within dependencies of web module, add the following. Add execute Gradle IDEA. To simplify determining of UI components while using Selenite, you need to enable test mode by adding the special KubeTest mode property to the web app properties. So open web app properties file and add the following. So, if KubeTest mode equal to true, then every UI component will have the KubeID attribute. Let me show you an example. Let's inspect this submit button. Now we see only this set of attributes for this UI component. Let's restart the application and apply test mode. Now you see that submit button has KubeID attribute. So let's create a new Java class. Set name sales UI test and add the following. This is pretty simple test class with the single method in which we open our application, click the submit button to log into our application, click on the shop customers menu item to open the customer screen, click create button to create a new customer, fill the fields with values, click commit button to save the customer, and then we remove customer and log out. We will run our tests using a separate Gradle task. So open build Gradle. Within configuration of web module, add the following. By executing this task, we will only run files ending with uitest.class. Also, we need to download a special driver for the browser that will be used for testing. In my case, it is Google Chrome driver, which I have already downloaded. Another thing we need to do before the beginning of our test is to enable JMX remote in the setenv file. So, go to the deploy, Tomcat, bin, and edit setenv-bat or setenv-sh depending on your operation system. And uncomment the following lines. And save the file. Now we are ready to start our test by executing the Gradle task. Pay attention that I use special properties to define browser and browser driver location. Our test is passed. The last topic for today is continuous integration. Previously we have run our test manually and it takes time. Alternatively, we can run all tests from all modules using the special test Gradle task, but it is also wasting of developers' time. So we are going to use a continuous integration service to run tests and notify if something goes wrong. You can use any CI service on your choice. For instance, as a CI service for Cuba platform, we use Travis CI. Travis CI is a hosted distributed continuous integration service used to build and test software project hosted at GitHub. Now we need to enable version control system integration in Cuba Studio. Go to the studio, open the project properties section, click edit, select Git and click OK. REST API test and Sales UI test require a running application and take more time to execute, so we will exclude this test from execution on CI server. For that purpose, we will use a special JUnit ignore annotation. Also, we need to create a special file named travis.yml to tell Travis what to do. This file specifies the programming language used, the desired building and testing environment, including dependencies which must be installed before the software can be built and tested, and various other parameters. So let's add the following. So we use Java as a programming language, we use Oracle GK8. Before install we need to start and create our test database. To install our application we will use assemble Gradle task, and to start testing we will use test Gradle task. Now I need to create a GitHub repository for my project. I will name it Sales Test. After all preparations, we can commit and push our code. Now we are able to go to travis.ci.org and see the build process. When you run a build, Travis CI clones your GitHub repository into a brand new virtual environment and carries out a series of tasks to build and test your code. If one or more of those tasks fails, the build is considered broken. If none of the tasks fail, the build is considered passed, and Travis CI can deploy your code to a web server or application host. Our project successfully tested on CI service. The main goal of our video is reached. We have taken a look at several testing approaches and run our test on CI server. Thanks for watching.